Morning everyone. Today we'll be presenting our topic recommendation systems in the era of big data and AI, a comparative study. This presentation has been created by Leora Dias, Alvin D'Souza, Jaden Colasso, and Cyrus Gomes. In today's world, almost every digital platform uses recommendation systems to personalize what users see, and our goal is to explain how these systems work and why they are so important to us. With that, let us begin. Recommendation systems are personalized information filtering tools that predict what a user might prefer. Their main purpose is personalization, and today they play a major role in driving engagement, user retention, and even sales on digital platforms. We interact with these systems every single day. For example, Netflix recommends movies based on our viewing history. Amazon shows us related items using the customer also bought feature. Spotify's Discover Weekly creates personalized playlists, and YouTube suggests videos using our watch patterns. All of these platforms depend heavily on big data, meaning large amounts of users' interaction, behavior, and preferences are taken into picture. With the help of AI and machine learning, recommendation systems have become smarter and more accurate, learning continuously from how we use the platform. So in short, recommendation systems help reduce the overload of information and guide users towards the content they'll find most relevant. There are four major types of recommendation systems used today. The first is content-based filtering, CBF, which recommends items that are similar to what a user has liked before. It focuses on item features like genre, keywords, or descriptions. The second is collaborative filtering, CF, which works by finding users with similar preferences. Instead of analyzing item features, it studies user behavior patterns. Next is knowledge-based filtering, which uses specific knowledge about how items meet a user's requirements. This is useful in areas like real estate or travel, where preferences don't change very often. And finally, we have the hybrid system, which combines two or more of the above techniques. Most modern platforms use hybrid systems because they offer better accuracy and reduce weakness of individual approaches. These four methods form the foundation of most recommendation engines we see today. Content-based filtering. Content-based filtering is one of the most commonly used techniques. It recommends items that are similar to those a user has liked before. For example, if someone has liked the movie Inception, the system might suggest Interstellar because both are similar themes and genres. This method works by analyzing item features such as genre, keywords, and descriptions. Behind the scenes, algorithms like TF-IDF and cosine similarity are used to calculate how similar two items might be. More advanced systems use embedding, which convert items into vector representation so the system can detect deeper relationships like mood or style. One key advantage of knowledge-based filtering is that it doesn't rely on other users. It's more personalized. Even if you're a new user, as long as you've interacted with a few items, the system can start recommending similar content. However, a limitation is that it may create a filter bubble, meaning users keep getting recommendations of the same type over and over again without creating much diversity. Still, because of its simplicity and personalized strength, content-based filtering is widely used across platforms.
Is collaborative filtering, which finds similarities among users or items. In user-based CF, if user A and user B have similar tastes, A will get recommendations based on B's choices. In item-based CF, if two movies receive similar ratings from many users, they are considered related. Third is knowledge-based systems, which are dependent on explicit domain knowledge, like recommending apartments or cars based on user needs rather than past ratings. And finally, we have hybrid systems which combine two or more of these techniques to overcome issues like cold start, sparsity, and lack of diversity. Let us talk about the architecture of a modern recommender. This is a part of paper 1. Let us work at how let us see at how this works conceptually. It begins with data collection. So the user is gathering profiles that include age, preference, location, and past interactions. Simultaneously, we gather item data like genre, price, and brand. These are then fed into a model, which could be a collaborative filtering algorithm or a deep neural network or a hybrid model. The system outputs personalized recommendations, which are then refined as the user interacts more with the platform. In short, user and item data are given to an algorithm and you get personalized output. Some of the challenges in recommendation systems. So, while recommendation systems are powerful, they face several real world challenges. The first one being data sparsity. Users often rate very few items, and this leaves most of the matrix empty. Then you have cold start. For new users or new products, there's not enough data to make accurate suggestions. Scalability. So you can imagine a platform with millions of users and products running real time recommendations, and it becomes computationally very heavy. Diversity. Algorithms may over recommend popular items, reducing novelty. And finally, privacy. Since these systems handle sensitive user data, that's always a concern. To tackle these, researchers use methods like matrix factorization, deep embeddings, hybrid models, and increasingly privacy preserving techniques such as federated learning.
As we already know, big data plays a very pivotal role in recommendation systems. The four V's of big data: volume, variety, velocity, and veracity. Volume deals with the massive amount of data such as ratings, logs, text sensors. Variety is the structured and unstructured, that is, your videos, images, and your reviews. Velocity is for real-time data updates. Veracity is for ensuring reliability and accuracy. Big data frameworks like Hadoop ecosystem, HDFS, Hive, Pig, MapReduce, Spark ecosystem, fast and memory data analysis supports MLib for machine learning, used to scale recommendation computation for millions of users. Applications of big data driven recommendation systems for like e-commerce sites such as Amazon, personalized product ranking and upselling, e-governance, smart cities for proper resource recommendation and citizen engagement, sustainability, sustain.ai recommends eco-friendly options and much more green options, healthcare, clinical decision support, personalized treatment suggestions, education's MWCs, course recommendations using BPR models, such as like if you do an intro course in a particular field, it will recommend something of an more intermediate or an advanced course in that particular field. The second paper, AI-driven personalized movie recommendation. Our objective for this paper was to design an AI-based movie recommendation system using content-based filtering and doing sentimental analysis on movie reviews for positive, negative, and neutral reviews. Motivation: traditional CF suffers from cold start problems, lack of interpretability, limited user engagement. This model enhances personalization using NLP and sentiment-aware insights. Methodology for the paper was data collection. We use the TMDB dataset, which is the entire dataset for movies. It's which has metadata like genres, cast, crew, directors, overview, and keywords. Feature extraction, text pre-processing, tokenization, stemming, count vectorization. Converts metadata into numerical vectors. Recommendation generation using cosine similarity finds movie closest to the user's favorite in vector space.
So, as per the paper, AI driven personalized movie recommendation, The methodology is based on sentiment analysis. So this entire paper works on a dataset of 50,000 reviews, both balanced, positive as well as negative. It has used three models, namely random forest, logistic regression, and naive Bayes. The main feature that they try to find out in this paper is TF-IDF vectorization, and the output is obviously positive or negative sentiments per movie. For this paper, they have used four algorithms, and each of them have been compared as per their accuracy and strengths. The first model, random forest, has the highest accuracy of 92%. It is best balanced between precision and recall. The next algorithm, logistic regression, has a 90% accuracy. It has a stable performance and it is linearly separable. The next model is Gaussian naive Bayes. This has a 88% accuracy and it is efficient for more of continuous data. And the last model, decision tree, it performed the lowest at 85%, but it is easy to interpret, and the only problem it has, it is prone to overfitting. So in conclusion, the recommendation systems are the engine of personalization in digital platforms. We have done research on two papers. The first paper gives a comprehensive understanding of the entire ecosystem and its challenges, and the second paper demonstrates how AI driven solution can be done using integrating NLP as well as sentiment analysis for personalization, and together how both of them can have a rule based evolution into deep data driven intelligent recommendations. Okay, the future research of these papers is firstly explainable AI, XAI. It will explain why a particular suggestion is given to you. So if you are suggested a particular movie, it will say why this movie has been suggested to you. Next one is fairness awareness systems. This will help in reducing bias in data to make sure that the data is actually both equal in positive as well as negative reviews. Reinforcement learning models, these systems that can actually adapt dynamically to the user feedback. Next is federated learning. This is having privacy preserving training. So it doesn't just go to each and every person's data, but keeps it masked so that no person's privacy is uh, harmed in this case. And then finally, multimodal inputs. So not only integrating reviews, but integrating text, audio, video, and other contextual data for higher recommendations. Thank you.